Okay, in this section, you're going to learn about the other four trigonometric graphs, which are tangent, cotangent, secant, cosecant. I talked a little bit about them last week, but I'm going to review that again. And then also be able to identify translations and transformations of secant, cosecant, cotangent, and tangent. Okay, so again, the best way to graph these, we're going to call this 1, 0. And then I'm going to also do these are both negative. And the last one. Okay. So for tangent sine over cosine. So all four of these are going to have asymptotes. The easiest thing to do when you're graphing any of these four, tangent, cotangent, secant, cosecant, is to identify where your asymptotes are first. Okay? So if we're doing tangent x here, or tangent theta, whatever you want to do, this is theta. Tangent sine over cosine. So where are my asymptotes going to be when what's 0?
Cosine.
When cosine 0. Because sine over cosine, when we have 0 in the denominator, is where we're going to have an asymptote. Yep. So when cosine is 0, cosine is x, so that happens at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, to infinity, both directions, right? So I'm going to go ahead and draw this in. This is pi over 2. And there's pi. There's 3 pi over 2. Negative pi over 2. And there's pi, negative 3 pi over 2. Okay, so it would help to write it actually right here. Okay, this is pi, negative. This is pi positive. Okay, so now I've got my asymptotes drawn. Now I'll just do this one in black. So it's going to be what value when sine is 0? What's the value of tangent when sine is 0? 0, because 0 is in the numerator, right? So everywhere sine 0, that's going to be at 0, pi, 2 pi, 3 pi, so on. So 0, negative pi is here, and so on. Okay, so the issue now is I've used all of my axes, my 90-degree coterminal angles, and I just have points. So for me to do the rest of it, I'm going to have to use that 45, that pi over 4 angle. And at pi over 4, what's tangent? What's that? 1. And at 3 pi over 4, negative 1. 5 pi over 4, or positive 1. 7 pi over 4, negative 1. Okay, so it's going to be, let's just call this 1. So it's going to be 1 here, and negative 1 here, and back to, at 5 pi over 4, it's back to 1. Can I get the idea? At negative pi over 4, it's negative 1, right here. Right? So if I just focus on these two asymptotes in graphing, I know it's going to go up, forever getting closer to that asymptote in that direction, and I'm going to go down in this direction. And now that I've got one pattern, that's the same pattern that will repeat forever, with this point being where it changes its inflection, right where it's at 0. I don't know how I got 1 there. It's going to be down here, and up here. And you can see the next asymptote, and it's just going to continue with that general shape forever. That's tangent. Okay, we talked about this last week, but what is the period of tangent?
Pi.
Pi. Because you see it only takes pi from negative pi over 2 to pi over 2 for it to start repeating again. Okay, so that means if I have a problem like this, where it's just going to be a period change, for me to figure out the new period, I take pi over 2, not 2 pi over 2. Sine and cosine, I use 2 pi. Tangent, its period is pi. So to find the new period, if it's tangent 2x, it's going to look exactly like this, except now it's going to take pi over 2 to repeat instead of just pi. So this number would actually be pi over 4, and pi over 4, half of what it used to be, because the period's half. Follow that?
Yeah.
Okay. If I added a translation up, this point where the point of inflection happens will be at 1 now instead of 0. If it were negative 1, the point of inflection happens to be negative 1 instead of 0. Okay. If I add in something like that, that means every point, once I've got it graphed with the right period, it's going to shift right pi over 2 units. Okay, so all the rules we used for transformations of sine and cosine follow. The only difference is you have to be careful on finding the period, because the period now is pi over whatever that coefficient is, not 2 pi. Okay. Now cotangent, I'm going to do it right below. Where will it be undefined?
Where sine equals 0.
Where sine is 0, so that's going to be 0, pi, 2 pi, 3 pi. If this is pi over 2, this will be pi. 0 and negative pi. And then I'll go over 4 more. Negative 2 pi. And 1, 2, 3, 4 more. 2 pi. So those are my asymptotes. It's going to be 0 everywhere what? Cosine is 0, right?
Mm-hmm.
So that happens to be at pi over 2. All of these halfway through. Okay? So far, same similar process, totally different asymptotes though, and totally different point of inflection, where it changes concavity, where it changes from concave up to concave down, point of inflection. Okay? And now we need to figure out, is it going to go right to left or left to right? And we're going to do that using the pi over 4 again. What's cotangent of pi over 4? Don't do this to me. Well, what's cotangent of pi over 4? Imagine the unit circle in your mind. What's the point at pi over 4? Root 2 over 2, root 2 over 2, right? And cotangent is cosine over sine, which is 1, square root of 2 over 2 over square root of 2 over 2. So I know at pi over 4, cotangent is 1. Well, here's pi over 2. Pi over 4 is right there. So I'm going to start seeing it's going to go down from left to right. Tangent goes down from right to left. Okay? So the difference in the two, asymptotes are shifted, point of inflection is shifted, and the slope, that's my phone, just ignore it. The slope of the curve is going to be positive in tangent, negative slope in cotangent. Okay, but the thing that's going to help you the most is graphing your asymptotes, because then you know you're going to be just focus on one period. Once you get that pattern, then you can just copy that pattern to infinity. Okay, same deal is true on any transformation of cotangent. You're always going to use pi over whatever that coefficient of x is to find the new period. Other than that, translating left, right, up, down, amplitude, all same rules follow with these two. Okay, looking at, now I'm going to do them next to each other. Let's do cosecant first. Stop. Come on, eraser. Thank you. Okay, you're going to have asymptotes here too. What is cosecant? 1 over sine. So anywhere sine is 0, cosecant will be undefined. Where is sine 0 again? Think about your unit circle. Where's y 0?
0.
0, pi, 2 pi, 3 pi, so on. 0, pi, 2 pi, and so on. I could go on. Okay, so I know what's the period now of cosecant?
Pi.
You think it would be, but let's play with it a little bit. Where is cosecant equal to 1?
Everybody goes in this.
Well, it's 1 over sine. Where is sine equal to 1? Pi over 2,
Yeah.
3 pi over 2, right? So pi over 2, it's 1. 3 pi over 2, what is it at 3 pi over 2? Negative 1. And at negative pi over 2, it's negative 1. Okay? Well, if I superimpose sine here, there's your sine graph. These are your asymptotes. It's the inverse of sine. And I know it's going to go, this is going to be cosecant. So the point where sine is 1 is kind of the vertex of that. It's not really a parabola technically, but it's the best example of what it is. So now tell me what the period is of cosecant. How long does it take to repeat its cycle? It's going to do this again. So this is one complete cycle, right? So 2 pi. So it's going to have the same period as sine. Do you see that?
Mm-hmm. It just doesn't connect.
Yep, it'll never connect, but you can see the pattern. And it takes 2 pi to start that pattern over again. That's what period means. Okay. Now, if we do the same thing for secant, it's 1 over cosine. Cosine is 0, pi over 2, 3 pi over 2, and so on. And negative 3 pi over 2. Okay? It's going to be 1 where cosine is 1. Well, cosine is 1, 0, pi, 2 pi, 3 pi. There's pi, and it's negative 1 there. Going to be -1 here. And I want to get one more. Well, that's going to be enough, but let's do one more up here. Same idea now. Cosine, if you remember, starts here. Looks like that. So secant uses that point as its vertex. Look where its asymptotes are compared to cosecant. And it also has 2 pi as its period, just like cosine. So sine, cosine, secant, cosecant, same period. Tangent, cotangent, same period. They all have different asymptotes, though. And let's compare cosecant's asymptotes. Where are they? 0, pi, 2 pi. Which one is it closely related to? Tangent or cotangent? Which one has the same asymptotes? Cotangent. Cosecant, cotangent, same asymptotes. Secant, tangent, same asymptotes. Same point of undefined. You start recognizing these patterns and what's paired together, and it will help you in being able to see a graph and understand what shift might have happened. Okay. Again, same is going to be true here with any transformations. If I say 2 times, the new period will be pi, 2 pi over 2. Okay. All the other transformations are the same. If it's plus pi over 2, it means it shifts left pi over 2. If it's plus 2 at the end, it means it shifts up 2. If it has an amplitude change, that's just going to stretch any of these graphs. It's going to make that a lot more of, greater than 1 amplitude will stretch it up. Less than 1 amplitude will flatten it out. Normally on web work, you're not going to be asked to have to guess what that amplitude is because you really have no frame of reference, especially because they're all starting at 1, and you really can't see, if it's a line, you can kind of see the stretch, but when it's like this, you can't. So normally, you're not going to be asked to do transformations with amplitude. It's going to be more phase shifts, translations up or down, and then the period. Okay, but this section now is going to focus on those 4 graphs and transformations of those graphs. Okay. So getting to the point where you can kind of repeat these or actually even visualize where the asymptotes are in your head will really start helping you on these problems, going back and forth from graphs to functions. All right.